Good morning, good afternoon, and good evening, ladies and gentlemen. And in today's video, we're going to be looking at how to find the inverse of a quadratic function. Now, when we're working with quadratic functions, unlike with the linear functions we looked at before, when you actually take the inverse of it, you're going to find you don't actually have a function. Now I'm going to show you what you would do with that a little bit later on. But first, let's look at this example, and I'll show you the steps of how you would take the inverse of a quadratic function. So, the first absolute thing you want to do, if it's not already in vertex form, you want to turn it into vertex form. So turn into vertex form. Now we would do this using completing the square. So if I want to complete the square, remember your first step when you want to complete the square. So I'm using this in a different color, just so you know that this is the steps for completing the square, is you want to factor the common factor in the first two terms. And only the first two terms. So I see here that my first two terms here are 2x and 4x. They're both divisible by 2. Now you only want to take out the number, even though I could take out the x, but you only want to take out the number. So I'm only going to take out the 2, because you want to be left over with an x squared without a coefficient beside it, plus 2x, and we are leaving the 5 alone. The next thing you do is you are going to divide your second term by 2 and square it. Okay, so what you're going to be doing here is you're going to be adding and subtracting what you did above. So you're not touching the x squared, but in your middle term you have 2x. Now you only care about the 2 really, so you know that 2 divided by 2 is 1, and 1 squared is 1. So what you're going to do is you're going to add 1 and subtract 1. Okay. Once you've done that, you're going to take out the minus 1, and the minus 1 is going to multiply with the 2 when it leaves, because if it's leaving the bracket, it has to be multiplied by the 2. So it multiplies with the 2, making it minus 2. Now, if you notice inside the bracket, this is a perfect square trinomial. So I can turn this into x plus 1 squared plus 3. Okay, so that's like a little bit of a mini review there on completing the square. So it is now in vertex form. Now that it's in vertex form, we want to change our letters. So I'm going to do this in the next page here. All right, so we now have it in this form. Okay, so your second step is to change position of your x and y, and isolate y. In this case, we're using f of x. So we can change it to y just for simplicity's sake. So we can change this to y just so that It's a little simpler. Alright, so your first step is you're changing the position. So this is now x, this is now y. Okay, and you want to get y by itself. So I'm going to subtract 3 from both sides, giving me x minus 3. I'm going to divide both sides by 2, so I'm going to have x minus 3 over 2. Now, to get rid of the squared, you have to take the square root of both sides. And remember, whenever you take the square root of both sides, you're always going to have a positive and a negative answer. And finally, subtract 1 from both sides. Okay, so this is my inverse. Now, let's see whether this is a function or not. Now, if I were to graph, so I'm going to graph this. So if I were to graph my original function, the 2 times x plus 1 squared plus 3, I already know that it has a vertex of -1, 3, and the y-intercept, if I found it, well, does it have a y-intercept? And in this case, it definitely would have a y-intercept, because if I made x equal to 0, well, what would I have? Well, you're going to have y is equal to 2 times 0 plus 1, which is 1, squared, plus 3. So that's going to give me y is equal to 5. Do I have any x-intercepts? Well, that would mean making y equal to 0, and in this case, you definitely would not have an x-intercept. Because if I made y equal to 0, you're then going to subtract 3 from both sides, and you're going to end up having to take the square root of a negative number. You can't take the square root of a negative number. So there's definitely no x-intercept. So knowing all this information, so let's put this into our graph now. So knowing all this information, you know you have a -1 and 3, y-intercept at 5, and my a value is positive, meaning it's going to be facing upwards. So you can see this is definitely a function, because if I did the vertical line test, I only touch it once. On the other hand, if I tried to graph my other function here, my plus or minus square root of x minus 3 over 2, minus 1, do I have a x-intercept here, or a y-intercept? Now, the best thing about when you're doing inverses, the inverse switches your x with your y. So, whereas before my y-intercept was at 5, now in the inverse, the x-intercept is at 5. And now I don't have a y-intercept. Okay? So knowing this, and this is a square root, so at 5, 1, 2, 3, 4, 5, we use a different color here. Let's go with green. So at 5. Now the plus, so this represents the plus squared x minus 3 over 2 minus 1. And this, the lower half, represents the minus squared x minus 3 over 2 minus 1. So the plus and minus always represent two simple halves. So the plus represents the upper half, and the minus represents the lower half. So the plus represents upper, minus represents lower. Alrighty. So when I see this, if I tried to do the vertical line test here, you can see I'm touching it here, I'm touching it here. It is not a function. So how would I make this into a function? I'm going to show you this in the next slide here. So how you have to make this into a function is by doing something called restricting the domain. Now, obviously, if I looked at both sides together, it's not going to be a function. So what you're going to have to do is you're going to have to pick one of the branches. So you can do this two different ways. You can say method 1, so method number 1 is that you can shade the right branch of the original parabola. Okay, and when I say right branch, I mean this. So obviously this is my axis of symmetry. So everything here would be my right branch. This is actually the branch that coincides with the plus x minus 3 over 2 minus 1. So the right side of the branch coincides with the plus, and the yellow side, this left side here, coincides with the minus part. Now that's always going to be true. The left side always coincides with your negative part, the right side always coincides with your positive part. So in method 1, I am only going to choose my right side. Now my right side, I know that this happens after negative 1. So this would mean my domain now would be, so if I look at my original function, so my original function being 2x plus 1 squared plus 3, so my domain would have to be x such that x is greater than or equal to negative 1. This basically means everything from there and up. This also means that I'm only looking at my green line. Now, a second method, now this would definitely make it a function because now I only have this left part here and I don't have the bottom part. The second method is to shade the left branch. So if I were to use this branch here. Now if I'm using this branch, it's not greater than or equal to negative 1, and it would be less than or equal to negative 1. Okay? So with that, we now know that it's definitely going to be a function. Okay? And in which case we know that my inverse would be coinciding with this one for method 1 and this one for method 2. M1, M2. And that's how you make it into a function. And that is inverses of the quadratic function. I hope this has helped everyone understand, and please let me know if you have any questions. Enjoy. Take care.